like to welcome you all to the August HPC Best Practices webinar. Today's talk is about the Kitware Software Sustainability Matrix. It's going to be given by two folks from Kitware, Bill Hoffman and Will Schroeder. We would like this session to be interactive, so we have a Google Doc that we like to use for Q&A, and then we'll ask Bill and Will to come through afterwards and write down some answers to the questions so that we can capture those. If folks forget and put things into chat, I'll try to move them to the Google Doc. And we'll stop along the way as seems fit to try to ask questions and then have questions at the end, but the Q&A document is also a way to get to things that we don't have time for in the session. We would also really appreciate your feedback on this webinar and other webinars in the series. So there's a link, and I'll be putting these in chat in a few minutes. We would really appreciate your input, and we would, at any time after the webinar. I'm sorry, somebody's saying that they can't hear me, but I can't respond yet. We will be publishing archives of the webinar, so if any of your colleagues are missing this and are interested, you'll receive, if you registered for the webinar, you'll receive information about where to find the archives, and you can forward that as you like. So with that, I will stop sharing and hand over to Will and Bill.
All right, welcome everyone. We're going to be talking about software sustainability. Go ahead to the next slide, Will. And the next one. All right, so I'm Bill Hoffman. I'm the CTO here at Kitware. I'm one of the founders. I've actually got a fairly short, boring list of jobs I've had in my career. I was at GE Research from 1990 to 1999 in a computer vision group, and then left to help start Kitware with Will and some other folks. And I've been in Kitware ever since, even into 2024. Need to update this slide. In early 2000, I was fortunate enough to be at the right place at the right time, and we had some funding from NIH that we were able to create a new build system called CMake. So I'm pretty well known in the world as the guy that created CMake. I'm also known as Kitware guy, and on a personal level, I'm known as a guy that runs ultra marathons in sandals. And I'll let Will kind of introduce himself here. If he wants to unmute.
Thanks, Bill. Yeah, so Bill and I and three others started Kitware. I was CEO for a while. I stepped down about 6-7 years ago, and I'm having fun as what I call an opportunity catalyst. I started out at GE Power Systems in Schenectady, New York, transferred over to GE Research, and then in '98, we started Kitware. Right now, what I have fun with is being a VTK developer. I was one of the authors of the original VTK textbook. I'm also advocating for open source and open science. And on a personal note, my wife and I love to sea kayak. I'm actually living in Maine right now. Okay, Bill.
All right. Next slide. Okay, I wanted to mention here that Kitware is part of the CORSA team. And as part of that team, and we're also promoting, foundations for projects, but our specific area, we're going to work on the metrics and sustainability scorecards. So I just wanted to get that out there, and if people had suggestions for things they'd like to be in metrics for software, we'd love to hear from you about those projects. Go ahead to the next slide, Will. So Kitware is, as Will mentioned, we started really the company around VTK, the visualization toolkit. We're a visualization company, and now we've grown into these other areas. We have a large computer vision group that works with DARPA and does a lot of machine learning and AI work with computer vision. Data and analytics groups that handle large data sets and work with web applications. The scientific computing group is probably how most of this crowd knows Kitware, through software like ParaView and VTK. We also have a medical imaging group, which is where CMake came from, actually out of a medical project. And then the Software Solutions Group, which works on projects like CMake and CDash and CTest, and essentially making better software processes and tools to go with that. Go to the next slide, Will. So Kitware, I'm talking to you from Clifton Park, New York. That's in upstate New York, about 3 hours north of New York City. And that's our headquarters, which is probably about 20 minutes away from GE Research. But we've sprouted some other offices around the country. We've got Minneapolis, Minnesota, which we just started last year, Santa Fe, New Mexico, conveniently located in between Los Alamos and Sandia. And in Carrboro, North Carolina, we've got an office down there, and Arlington, Virginia, conveniently located next to DARPA. And we've also got a subsidiary in Lyon, France, that does a lot of work with our tools there. Go ahead to the next slide. And we work on applications, from web, desktop, mobile, cloud, HPC. And this is just sort of a sampling of our platforms. Originally we were going to create the company and build commercial software we would sell that was built on top of VTK. Turns out that really isn't exactly how things worked out, but we got really good at building long-lasting software and open source software that we didn't sell, but we sold services around. And I think that gives us a good credibility on what is sustainability. Go ahead to the next slide, Will. So one way to look at it is sustainability is the expectation that software used today will be available in the future. Open science, along the same lines, published computational results can be reproduced. Related to this is that the data is available into the future. Go to the next slide, Will. But, sustainability, like anything, is not that simple. What does it mean to be available in the future? Platforms change, hardware, software changes, new compilers come out. These things are constantly evolving. So sustainability is obviously going to involve some ability to adapt to new environments, and change as new, obsoleted, programming languages change. I remember the original VTK was wrapped into TK. Tickle has pretty much fallen out of favor these days, but VTK is also wrapped in Python now. So that was a sustainability move, but APIs change. And I think important to that sustainability and how our tools have lasted for 25, 30 years is having strong build and test processes, right? These are reproducible nightly processes that the software goes through anytime any changes are made, and they can evolve over time, and allow for technical innovation. Go to the next slide, Will. Another meaning for sustainability would be, reducing the cost of developing the use and using software. More energy efficient computing infrastructures, energy efficient software and algorithms, virtualization, reduced server loads, more efficient testing processes. You know, what can we do with less power? It's another way to look at sustainability. Next slide. So let's talk a little bit about why we care about sustainability. So software has completely taken over the world. It's been really amazing to see, you know, over the past 30 years, how much things have changed and how much open source has changed. You know, when Kitware started, open source was relatively new and people hadn't figured it out, but it seemed like it was a good thing. And I like to show this, you know, I'm a runner and I've got my fancy watch. But if you dig deep enough in the menus, you can see that the watch is built on top of some of the same software that we're using in HPC applications, like curl, distributed on MIT license. You can see it contains other licenses. I can go in and look and see, you know, OpenSSL for more copyright information. And this is just on my watch. You can go into your car, basically anything with a computer, it's got open source software in it now. And I think software and innovation is really important. I mean, I think Kitware was involved, you know, the Insight Toolkit where CMake came out of was, you know, the National Library of Medicine put out this data set, Visible Human Project, and then they said, you know, the data is great, but we need software to go along with that, you know, because if we want to move the state of the art, we need to not have grad students re-implementing papers all the time. We should have a base of software that gets built upon. And modern societies are increasingly relying on this software. Like I said, it's in your watch, it's in your car. You can't just create something and throw it away. It's not viable to build large, complex software systems that we're using today. Even the AI-based stuff is built on all these building blocks. Next slide, please. And I think the sustainability of software also goes for open science, built on these sort of three pillars of open access, open source, and open data. And it all gets down to reproducibility. Go down to the next slide, Will. So if you go back to the 1600s, and the Royal Society, you know, take no one's word for it. These people were, you know, really militant about their reproducibility. If it wasn't reproducible, it wasn't science. Go ahead to the next slide, Will. Unfortunately, that lesson really wasn't learned. So we can go back 350 years later. There was an article in Nature from 2012 and found that more than 90% of papers published in science journals describing landmark breakthroughs in preclinical cancer research were not reproducible. So arguably just plain wrong. So reproducibility and sustainability are really important to the scientific process. Go ahead, Will, next slide. Just a little slide that, you know, showing that if articles are freely available online, they're more likely to be cited. So be selfish and share and increase your impact. Next slide, Will. So sustainability for innovation. So open infrastructure is sort of a springboard for innovation. Avoiding reinventing the wheel, reducing technical debt or bankruptcy. It's, you know, for any of this modern software that we're working on, it depends on this open source, open infrastructure, and that software has to be maintained and has to be sustainable. Go ahead, Will. So takeaways so far, scientific research depends on software, lots of software and more complex software. Research and software both need to be reproducible. Agile innovation relies on reliable computational foundations.
All right, Bill, thanks a lot. I'm going to take it from here. David, is this a good point for questions, or should I just keep marching?
We do not have any questions yet, so
All right.
go ahead.
That's excellent. Okay, so, we've talked about the importance of software and the importance of reproducibility. So it makes sense that we somehow measure software, measure the health of software, measure the quality of software in order to make it better. So there's a lot of things we can do. We can improve software quality. We can build healthier communities. It turns out that communities are vital for sustainable software systems. We can also monitor the impact of software and sort of get a sense for who's using it and why, and possibly make it even more useful and impactful to people. And this is all about identifying areas for improvement. But one thing that's a little bit challenging with measuring software is that there tend to be objective measures and subjective measures, and we'll talk about this going forward to some extent. Objective measures are things like, does the software compile? How many lines of code is it? Are there warnings or errors during compilation, things like that? Very cut and dried. Subjective measures are things like, is the community happy? Do people get along? Is there governance? What's the process look like for merging software into the main branch? So there's this balance. I think you need a little bit of both. We'll talk about it, as I said. And one thing that I've come to realize is that software quality is not equal to software sustainability. And what we found is that, you can create really great high quality software. Imagine a piece of software that is perfect in every way, returns the same result every time you run it, and no compile, no warning errors, all that kind of stuff. But at the same time, if nobody cares about it, it's not going to be sustained going forward. If the impact is near zero, or it just doesn't have value, chances are it's not going to go very far. So that's where the community comes in, and that's where these squishy subjective characteristics like usefulness, technological artistry, using software because it's cool and fun, market forces certainly, and cultural influences all sort of play into making software more sustainable. So from our historical introduction to this actually started a long time ago. We had no idea that we were computing metrics or we were headed in the direction of measuring software health and sustainability. We were engineers and we were working at GE Research, and this program was introduced in '95 by Jack Welch, the CEO at the time, which is across the company, measure and improve quality. Of course, being in a research center, we looked at each other like, this is crazy. But being very creative people, we realized that we could, if we thought about it, we could use this program to conceive a way to test software using, it wasn't CMake, CTest, and CDash. They didn't exist at that point, but the precursors did. So we created some tools basically to test software and to display results across the web or to a team. And what we used it for is basically to identify areas for improvement and to improve its quality. Again, it's a necessary but not sufficient condition for sustainability. But we started in '95 and we ran with it for a long, long time, and we still use it. It's still central to what we do. And CMake, I suspect a lot of folks have seen CMake, CTest, CDash being used. Basically, tools, platforms like VTK are tested on a continuous basis as code is merged every night during release processes. It's just continuously tested. And we look for all sorts of things like warnings, errors, failed tests. We have thousands of tests, for example, in VTK that have to pass in order for merge requests to be able to be integrated into the main branch. things like static analysis, dynamic analysis, code coverage, and so on. All these things are being done, and at the time, we didn't call them metrics, we just called it testing. It worked out well and still works out well. As a matter of fact, our tools have become quite sophisticated. You can go on the website, CTEST-C-, and you can do things like search for relevant results of the test process. Here we're searching for platforms, testing platforms that are Microsoft platforms from the nightly expected testing pool. And we get a list of things, and we see that there's some failures occurring during the test, and we can sort of burrow in and figure out why that's happening. You know, is it an update to the software, to the operating system, to some library that Microsoft depends on? Who knows? But it's very easy to sort of tunnel down and find out what's going wrong. So here's some other examples of measurement metrics. We're not the only people doing this. Lots of others have. And this is just sort of a small sampling. We've talked about CMake, CTEST, C- as a software quality metric. But there's tools like OpenHub, repo review from Scientific Python, OpenSSF. They have a scorecard, which is quite interesting. The Linux Foundation's Chaos Community Analytics. You guys at Oak Ridge have developed some excellent assessment tools. And we'll go into the Kitware Sustainability Matrix in a little bit more detail. So this is what this looks like. OpenHub, you can go onto the website, type in a tool name like VTK or ParaView, and you get all sorts of interesting information. And it typically is weighted towards community, number of lines of code, the activity of the community and commits per month, and also the number of contributors per month in the community. And there's other information like the languages that the software is composed of and that sort of stuff. It's fun to go in there and look around and see how your favorite software package is doing. A very simple Scientific Python repo review. It's a repository style checker. It's basically a framework for building checks to see if repositories follow guidelines. You can find it here. This is what it looks like. Basically, we type in our repo name. We run it on the main branch, and then it runs quickly and returns a bunch of information about, you know, it has a README, it has a license, it has documentation, it has tests, and so on and so forth. And, you know, we have check marks or not, depending on whether these tests pass. So very simple, but quite useful and powerful tool. The OpenSSF scorecard is about security, and it's fully automated, which is sort of cool. And it basically does an automated evaluation covering about 5 categories or 20 tests. Categories include code vulnerabilities, maintenance, continuous testing, source risk assessment, and build risk assessment. And again, there's a link to a website where you can sort of see what's going on. And this is what it looks like. We're running on 2 different repositories. This is F-Droid client, and you can see it's not doing so well in a couple of cases, but it's passing in others. Whereas this one, which is the scorecard OpenSSF report, it's very good. It's just got 1 or 2 spots where it's falling behind. But all in all, you get a sense for the quality and health of the software and from the perspective of security. The Linux Foundation has a set of analytics referred to as Chaos. It's focused on creating metrics models, and software to understand open source community health. As of when I created this slide, there were 89 metrics covering all sorts of aspects of open source software, including the organization, platform, software contributions, governance and leadership, life cycle, ecosystem, community, and so on. It's quite daunting. There's a lot going on. And many of the metrics are objective and many are subjective. So a good and fun objective metric is the elephant factor, which is the distribution of work in the community across organizations. And it's the number of organizations contributing that contribute more than 50% of the project commits. So you look at the number of organizations that break over the 50% mark, and in this particular test, there's one organization in the green, which is contributing, let's call it 2/3 of the work. So the elephant factor is 1. And the problem with that, it's like the bus rule, which is if you only have one developer that knows how software works, and that developer is hit by a bus, you're in trouble. Well, the idea behind the elephant rule is if that one organization is dominating the development of tools, that can be a problem. If they go away, if they sell, or they try to do something funny with the licenses, it can cause a problem to the community. Now, a subjective metric would be the burnout self-test, which is administered to developers. And, you know, it has questions like, I feel run down and drained of physical or emotional energy, and so on. We don't need to go through it all. But the idea is, how overworked or underworked is the community? How happy is the community? Is the community burning out? So, you know, you get a sense for the health and what's going on. I'm not going to really speak about this because I suspect you folks know way more about it than I do, but the Scientific Software Excellence Assessment is it's a survey that can be used to guide staff towards activities that would lead to beneficial improvements to a software project. In other words, how do we improve software, which is pretty consistent with what we've talked about so far. And there's the paper, one of the papers that I know of that you can take a look at if you're interested. All right, so let's talk about Kitware's Software Sustainability Matrix. I basically will give an overview, and then we'll talk a little bit about a case study and how we used it relatively recently to give you a sense for what's going on. So the idea is that we wanted to keep it simple. We wanted to avoid an excessive number of or very complicated metrics. And we sort of whittled it down, and this is all empirical at this point. We whittled it down to 4 core values. Each value was scored according to multiple simple metrics, and we'll show the metrics, some of the metrics in a minute. And the 4 core values are: what's the impact of the software? Do people want to use it? Is it impactful? Is it likely to be used because it does something useful? What are the risks? What are the competition? Are there risks to the technology that's being used in the software? The community health, and also technology. Is it cool? Is it something that is prone to support moving forward in time, like interoperability? So this is one way we look at it: impact, risk, community, and technology. Some of the metrics are value, business model, user base. Risks are the IP and license, the bus rule, security, dependencies, competition. Dependencies refer to, am I dependent on another tool that may go away someday? Community, what's the culture like? Is it a positive culture that encourages new members to join or old members to stay? What's the software process? Really important. Do we have a formal software process to make sure the software stays stable and robust? What's the governance look like? Are people happy with management of conflict, things like that? And do we have some sort of outreach to find new developers and users? And then technology, how ubiquitous is it? Does it run on multiple platforms, including things like web and supercomputer? Is it interoperable across platforms or in between systems? Can I easily use it in different tools? What's the architecture? Is it a powerful architecture, or is it a brittle, fragile architecture? And for a lot of people, having the latest and greatest technology is very important to moving forward. And we came up again with an empirical scoring process, which is weights impact 33%, and community 33%, and the risks at 16.6%, and technology at 16.6%. So again, all empirical based on, discussions in our small group. We can argue about whether any of this makes sense. So we know the metric set is incomplete, and we're fully aware that it's based on empirical information. It's a first stab at addressing the problem of measuring software quality, health, and sustainability. But the question that keeps popping up in my mind, is there a sort of a minimal spanning set of metrics? What are the, is it possible to identify a dozen or two metrics that do a pretty good job of capturing whether a software system is sustainable? And we want to go beyond just quality. In our case, we are interested in sustainability. So, and the thing is, we kept thinking about, okay, what does it mean to have objective metrics, like measuring CMake impact, for example? So our first attempt was, okay, let's measure impact by downloads. And we see at Kitware about 100 million downloads a year from our servers. It doesn't count other distributions like Linux, often is distributed with CMake nowadays. So, it's not really easy to infer customer base, and it's misleading to depend on downloads because a lot of build processes basically just very often download CMake just automatically. So, all right, what's an alternative approach? Well, we could look at the CMake usage. We know from a study by JetBrains in recent years that CMake usage is around 50%. And according to folks like SlashData, C++ has roughly 11.12 million users. So we can estimate there's actually 6 million users of CMake. So that is that's hard to automate. Downloads are easy to automate, but I would put more faith in the second alternative. And also impact is misleading because there's the impact of now, how many people are using it today, but there's also the potential future impact. If somebody develops a great new piece of software, I mean, it could be that in 5 or 10 years, it takes over the world or it takes over a segment of technology. So you can't really use impact easily to compare across systems. You can only sort of use it as a measure to improve where you are now, in my opinion. So again, it's about improving software and the reach of software. And there's also scaling effects. I like this little example because we have tools at VTK. We have tools at Kitware that are of very small scale and very large scale. We've already looked at CMake. VTK is sort of medium scale. It's about, call it 400,000 downloads a month. And then there's tools like Viame, which is a special tool developed by the computer vision group for basically computer vision in marine environments, like identifying things like starfish or whales or seals. But the number of downloads a month is, tiny. But to the NOAA, who is working quite closely with us, it's a very important piece of software. And they've outfitted a plane that flies over the Arctic seas, bearing Beaufort and Chukchi. And it basically does census surveys of various organisms. And they find it to be very useful and very powerful. So impact for them is huge. Impact for me, because I don't tend to want to count starfish, is not so much. So again, impact is a very tricky thing to get your head around. So some of the additional takeaways, we want to use metrics to improve software, not compare software. I think comparing software is a trap. We want to leave that to others to do. If you're in a funding agency or you're trying to prioritize efforts towards software, that's sort of a different computation, in my opinion. We want to get a better sense for what objective metrics we can find. We want to get a handle on subjective metrics and try and fine-tune what we're judging. And we also want to be mindful of biases, which can really subvert this whole process of measurement. And here's a case study. This is where it started about, I'd say 5 years ago or so. Kitware and the University of Utah, the Scientific Computing Institute, Utah SCI, we had our NIH R24 research grant, and the idea was to improve the sustainability of some of their flagship software tools, and there were 7 we were looking at. And what we decided to do is, first of all, we created this Software Sustainability Matrix empirically, and we wanted to focus on a subset of those metrics, including improving documentation, improving the build process using CMake, and supporting additional platforms, so not just Linux, but also Windows and Mac, etc. We wanted to re-architect their systems because they had a lot of great code, but oftentimes it was hard to reuse and include in other systems. And we wanted to replace their OpenGL graphics engine with something that was portable into the future. And we wanted to use VTK because we know with VTK, we're moving in the direction of away from OpenGL towards things like WebGPU, another discussion. But the belief is that VTK will be around a lot longer than OpenGL. And we also wanted to focus on interoperability so that other systems could use some of this great software that Utah SCI presented or has developed. And we did a pretty good job, especially at interoperability, which I'll show in a minute. We did a really lousy job with replacing their graphics engines with VTK because it's too hard. The software was pretty entangled and spaghetti-ish. And given the funding resources and so on, we just ran out of time. So we didn't get too far on that. But everything else we did very well at, I would say. And this is what we did. We would meet software engineers and developers. We would meet periodically and score the 77 key systems like Cleaver, Mesh Generator, Flow Render, Volume Renderer for microscopy, and so on and so forth. Ski Run, many of you probably heard about, Seg 3D, and so on. And you know, you can look through here and see that some of the systems look pretty good, and there are systems like Map 3D, which, you know, especially towards the technology end, are a little ancient. So we looked, and that's where we came up with our plan of attack. And what we wanted to do, in particular with Cleaver, which is the mesh generator tool for medical volumetric data, was to grow the computer, grow the community, increase its impact for users and developers. And we decided the best way to do that was to improve its interoperability. So that meant improving its build system and re-architecting it so that you could easily reuse Cleaver inside of other things. So once we did that, we integrated Cleaver with our Tram Visual Analytics platform. This is a new thing from Kitware, which is a Python-based platform for combining complex visual analytics tools. And we also created a 3D Slicer extension. 3D Slicer is a medical analysis and visualization tool. It's an open source tool. The development is spearheaded at Harvard Brigham and Women's Hospital. It's been around for a long time. It's based on VTK, ITK, and CMake and other tools. But anyway, once we created this plugin extension, the Cleaver downloads went from basically a couple hundred a year to about 30,000 a year. So people started really using it, and people are using it today to mesh their, you know, their CT scans of bone systems or skeletal systems and so on. So that worked quite well. So where are we? We're winding down. Basically, what we see doing in the future is 2 major tasks. We want to look at our current software process, which is a continuous integration, continuous delivery process, which is anchored at testing. And we want to replace that, not replace it, but augment that testing to include some metrics, which might include some of the metrics I referred to earlier. So we want to basically integrate these metrics into the continuous integration and delivery process. And we think the best way to do that is to take our current tools like C-Dash and C-Test, extend them in a framework way to support additional plugin metrics. So, we're imagining this is a concept of some sort of a web page or a web portal, where we basically, as we run the software through this process, we not only do software quality checks based on C-Test, C-Dash, but we also run continuous measurements of community health. And we also run continuous measurements of impact. And, there's all sorts of crazy things we could do, including things like, which is sort of a fun thought, is count the number of SPAC dependencies. But we can also do things like number of downloads, number of academic references, community size measures, and so on. So a lot of metrics may plug and play into this environment. What the right ones to use are, I don't know. And hopefully over time and feedback from folks like yourself, we can get closer to something that works and makes sense. But the last bullet on this page, as we add more metrics, it can, if we're not careful, really slow down software development. So we're going to have to balance the cost and maybe do these things in a periodic fashion rather than in a continuous basis, maybe every week or every month or something like that. But so we want to basically identify the spanning set of metrics. We want to automate as much as possible these metrics and the way we score them. And we think that there's a lot of room for software engineering research. For example, what metrics are important to real world software quality? What metrics are important to long-term sustainability? And of course, supporting some of the DOE and other initiatives going forward to make sure that we come up with something that is usable and helpful to people developing scientific research software. So that's it for me. And I think I will pause here. And David, do you want to take it away?
Sure. Thanks very much to both of you. We do have some questions that have come up. So I will ask those. Feel free to add more questions to the Q&A document, folks. And looks like we might have some time, so we might be able to open it up to actually people asking further questions. So the first one is, does software need to be, quote, sustainable in order for software to be, quote, sustained? i.e., are there examples of software projects that have been sustained for decades with lots of users that would score very low on objective software quality sustainability metrics? If so, what's the real definition of software sustainability?
Bill, do you want me to jump in?
Yeah, sure.
Yeah, this is a really, really good question. And that is why when we developed our Kitware metrics, our values, we included impact and we included community. Because we all felt that there is software, we've used software that's been around for a long time, but because it's so useful or so much fun or whatever important reason you want to come up with, that the community, which is developed as a result of the impact and value of the software, will do whatever it takes to take some software from one form and make it work elsewhere on another platform or as languages evolve. Quite frankly, I can't think of any off the top of my head. I'm sort of burnt, but I have a sense that this has happened in my career. Yeah, Bill, do you want to jump in there? Do you have any ideas?
Yeah, I mean, certainly there's software, and I think we're seeing some of this, like the XZ attack that happened. Like there's little pieces of software around here that, if you actually did sort of sustainability on them, they would rate pretty poorly, but they might be having a large impact and have a lot of people using them, which I think is important for doing this kind of work, to realize what those interesting but important pieces of software are, and trying to figure out how to make sure, they might be sustainable and they might have been going on for years, but they could be sort of the Achilles heel and bring down the entire world, sort of thing. I think you saw that with the Open SSL issue that happened, and then people tried to address that by finding a foundation and funding to sit that project in. So I think continually studying it, but yeah, certainly software could be sustained for many years, but not be in a sustainable way. But it's sort of teetering on the edge of some catastrophe, would be my take on that. Does that sort of answer the question? I know there was a lot of chatter going back and forth here. Like if you had lots of money plus grunt effort, could you still sustain the software?
Yeah, that was my question, Bill, and that was the example I thought of, was OpenSSL before and after the Heartbleed bug. Yeah.
All right, thanks. Another question. How do you measure if a piece of software written in the past has been sustained?
How do you say that again, David? I didn't quite catch that. How do you measure?
How do you measure if a piece of software written in the past has been sustained?
Okay. Yeah, okay. Earlier in the presentation, we talked about how sustainability is not that simple. So, you can say, well, if it still exists, then it's sustained, but that is a bit of an evasion, in my opinion, because it could be that if, say, 20 years ago, you wrote a VTK script in TickleTK and tried to run it today, it wouldn't run because we don't support TCL/TK anymore. On the other hand, if you wrote something in C++, there's a good chance it still works. We've been very careful with our API. So it's a hard question. If you're still using the software and it's still making a difference, you can argue that it's sustained. But on the other hand, if you want to pull out a dusty deck that ran 25 years ago and try and run it and it doesn't work, then the answer is maybe not.
All right. Another question. Have you done a scientific study that correlates your metrics to quality outcomes? Have you done any studies that show cause and effect, that improving a metric improves quality?
I would say, our testing processes that we use with CMake and CTest and CDash, have we done a formal scientific study of? No, I have not, but I do know that I have worked on systems without testing foundations, software testing processes, and I can tell you unequivocally, my personal experience is that the divergence in quality is significant. And I suspect Bill has more to say about that.
Yeah, I don't think we've done a formal scientific study, so the answer is no there. But yeah, just over the years of experience, seeing the impact of having things like CDash, and what we've seen, like some developers have left Kitware and gone to other companies like NVIDIA, and NVIDIA is actually very interested in getting CDash running at their site, because they're collecting up a bunch of former Kitware employees, and they all really miss having this dashboard on their software. It really does allow for large scale changes in the software that make you feel more comfortable. If you have to do some big refactoring, you can do it, you can check it in, you can go there and you can look and see if it's still doing what it was doing before, and compare it over time. And a shout out to Roscoe for helping support that software over the years, and other folks.
So maybe you have an opportunity for some software engineering research with NVIDIA. If you put this in place, you can do before and after. All right, next question. Can you please comment on how open source software commercialization and business models can help improve the sustainability of software? Many research software are difficult to maintain past the discrete one-time budgets allocated by a grant. So what are some of the options for financially sustaining software after these grants run out?
I love this question. So here's our a quick intro to our sustainability matrix. And you notice one of the metrics under impact is business model. So there's no question that in the research world, oftentimes we get a large grant or we get some sort of grant, we develop some software, we use it for a while on a project, and then the funding runs out. And then typically what happens, unless we're very lucky and there's a community that's built up and so on, that software can sort of fade away. So business model is important, and this is where I think Kitware does a really good job, is we basically approach our software platforms as engines of innovation. So we create stuff that's useful. Customers, often commercial customers, pay us to integrate that useful stuff into their products. We then use that money and any additional research money we get from working with various funding agencies and customers who are interested in R&D to basically build the next generation or improve the current generation of software. And we've been able to do this for, what is it, 25 years now, 26 years, because we create a vision for where the platform should go and where it needs to be in order to retain its usefulness and impact. And then we look around for opportunities with various customers and funding agencies to keep building on that platform and extending it into the future. Again, we've been doing this for decades. It seems to work well. I mean, you know, if the funding or commercial activity in the world dried up completely, yeah, we'd have a problem. But so far it's worked really well, and it's really key. The key thing is to have a vision and make sure that we're constantly trying to build on our platforms using various funding opportunities.
But I wouldn't say it's an easy thing to do. And it's difficult. You know, there's not, you know, the business model, the path that we've chosen at Kitware with open source software is to build these platforms and then try to bring in lots of customers that care about different pieces of them. And that does work. So something like, you know, ParaView was originally developed by by Kitware for Los Alamos, and then CMDA got involved, and then we've had various SBIRs. We've pulled in Army Corps of Engineers, NASA, and car manufacturers, and they all want some piece of it. But I think by pulling that community together around a company with a business model that's able to pull in a wide variety of funding sources, that's how we're able to keep these softwares moving forward. So having a company that has an interest in doing that, but it's certainly not easy, and there isn't a one-stop answer for every piece of software. It's hard work, and it takes dedication to an interest in that software and collecting people that are willing to fund it.
And also, I suspect a bit of creativity around identifying possible customers or users for the software.
Yeah, definitely.
Two other questions, which I'm hoping we can get to. I'm gonna, well, maybe three. Let's see, I'm gonna go out of order because one's more open-ended. Software that ran on DOS doesn't run on any currently available operating system anymore. It's just an example of software that's not sustainable. Is sustainability really an absolute measure of the worth of software?
I don't think it's a measure of worth. I think it's it's correlated. Yeah, this is where it gets really tricky, because I would argue that if a piece of software is really important, a community or a group of people will find a way to make it run elsewhere. I mean, we see that in the gaming world now. Old games are being resurrected because people had great fun with them. So I would then argue that if there's people are willing to put in the effort to resurrect old pieces of software, that in some sense it has a higher sustainability score than something that just fades away.
Okay, so since you don't have any scientific studies that provide insight into the value of these metrics, it seems there's room for improvement. Yes, having testing versus not having testing is clearly better, but that's like saying a person can survive better by drinking fluids versus not. That's not a compelling story. I guess that's more of a comment than a question at this point.
Well, I think it's a well, that that's a very vibrant image, but I would also say that there's still a lot of software out in the world that is not tested regularly. I mean, I work with academics developing research software, and I tell you again and again and again, they do not test their software. What they do is they develop software and they produce results for a paper and they move on. And then the next time they need to do something, they realize, oh, geez, it's not working anymore. So even though we all think that testing is a routine thing that everybody should do, I would say in many areas, people still don't do it.
And I think that goes along with automation, right? If that testing is easy to set up, or it can be set up by someone else, and then it gets tested, I think that it's not that people don't want to test their software, it's they don't want to take time out of the other stuff they're doing to do it. But if it's happening for them, they'll play along, is what I've seen.
Yeah, and I would also say, we're hoping to start a conversation around measuring health, sustainability, and quality. It's clear that we don't have a handle on this, and I don't think anybody does. But I think by, leveraging the experience of really talented software folks like you and others, and having this conversation, we can begin to whittle it down, and then hopefully someday have some more formal studies to start backing this up.
Okay, I'm going to try to squeeze in 2 more questions. I understand people have to move on, but hopefully we can hang out for a couple minutes more and discuss these. So first, maybe a quick one. Is there a relation between sustainable software and sustainable data or data formats?
Yes, I would go back and look at, the open science, the importance of open science, and that, the scientific method typically depends on lots of data and being able to access the data. It also depends on the methods, in which case we're talking about software for a lot of us. So you need both those together in order to create reproducible results. So yeah, they're related. They are very important to each other.
All right, and one last, which is maybe a little more open-ended. Does Kitware have tools which are adopting machine learning? If so, do you have any concerns about reproducibility?
Bill, you want to address that?
Oh, you're gonna throw that one at me, okay. Yeah, I mean, we have a whole computer vision team that does machine learning work. And I think some of it can be tested very similar to what's being done here, providing tests and making sure that what happened yesterday happens tomorrow. So I think applying some of these same tools to that should mitigate those concerns, but yeah. Do you have anything else to say, Will?
I mean, no, not really. Nothing intelligent.
Well, we'll get your AI model to speak for you.
Yes, thank you.
Yeah, we could ask the AI model, it would say everything's fine.
Yep. Trust
answered
me.
everything perfectly the first time. Oh, I'm sorry, that was a mistake.
All right, I want to thank Will and Bill for an excellent talk, and I want to thank everybody who attended today. We will get the announcement out soon about the September webinar, which will be late in the month, so plenty of time to prepare for that. Thank you all very much. Goodbye.
Thank you, David.
Thanks, everyone.